is the second part of the pick and place uh, lecture with CoppeliaSim. Okay, and in this part, we are going to continue from where we left last time. So last time, what I did was I did pick and place of a single block, but the movement was rather jerky. It just went from point A to point B without really respecting time. Here I'm going to show you how you can do it smoothly. So here is how. Here's what we'll end up with. So that's the block one, and assume that the red part is something which is an obstacle and we want to avoid hitting that obstacle. So that's where there is value in moving the block up to that via point shown in pink and then moving it down to the goal point shown in black. Okay, so there are three parts to today's lecture. The first part is specifying a path for the manipulator to move and see that that path is traversed in a given time. The second part is I will introduce what is known as a finite state machine to program a single pick and place. So pick one box and place one box. And I'm using finite state machines because they are very popular in robotics, and I've seen that many of robots are actually programmed to do complicated tasks by coding them as a finite state machine. So this will be very useful for you later on. And then finally, I'll generalize the finite state machine to do multiple pick and place, so multiple boxes. So let's get started. I already sent the CoppeliaSim file in the chat window. You can download that, but I probably will go quite fast today because there's quite a bit to be covered. So what I would suggest is you rather watch me do this, and then later on when I post the video, you can follow slowly. So this is where we left off last time. I'm going to just play the video of what we did. So this is pretty jerky motion, and so we're going to smooth it out first. So I'll stop. We don't need the camera view. I'll close that. We also probably don't need this. Let me open this first, the code, and then close the left bars. And this one, okay. Okay, so this way you can see the code and see the result on the left side. Okay, so the first step is for me to actually make this robot move smoothly from point A to point B instead of moving jerkily. Before doing that, let me just start this. So right now when I start, so let me first put in real-time mode and start this. You can see it just jumps off to this point and then moves haphazardly. Let me actually start the robot at this pink point first. So let me stop this. And so this is like a review of what we've done last time. We basically use this command, set object position, to put the manipulator in the position we want. Always the initialization function is the one which places the robot or places the robot at time t equals 0. And this function is called once, right? So let's put the robot in this via point, which is the pink dot, and so that it always starts here. Let's go. So now it started at the pink point, and then it clearly there was a collision, which is okay, and then moved down. So don't worry too much about the collision right for now. Okay, stop. Okay, so let's first get started in making the manipulator move rather slowly. Okay, so I'm going to comment out this part. Okay, and I will just focus on one move first. That is, can we get the manipulator to go from the via point to the picking point? So here to here, smoothly. So what I'll do is, there'll be a couple of lines of code, and instead of writing it down in the main function here, let me just make a function and let me call it move ik. And what I need to specify in the move ik is possibly I need to give it the initial position. Okay, I need to give it the final position, and I also need to specify how much time it goes from point A to point B. So let me specify the initial time as ti and tf. I'm just writing these variables because that way I can just generalize them. And what are these positions? Well, for position I, it's the start point, which is going to be the pink dot. So let me, so that is position via, right? The final position is the pick location, which is this. The pick location is the box location, so that point here. And then the time, well, I wanted this to be from 3 to 6. So why don't I just define that as T1 equals 3, T2 equals 6. I'm doing this only because then I don't have to, I can just change one number here and everything else gets taken care of. So Ti equals T1, the start time, and the end time is T2. Okay, so this is what I envisage that the manipulator would do. I still need to program move IK, which does the smooth motion from point position I to position F. So let me now start writing this function. Okay. Okay. So what is stored in position I? It's basically the X, Y, and Z position for the initial point. So let me collect that in a variable Xi, the first value, right? Position I1 is the X value. The second value is the Y position. Third value is the Z position. Okay. Similarly, let me pick up the final position. Okay, so once I do this, now the question is, how do you want the manipulator to go from point A to point B, or I to F? In the past, we've seen you can use linear functions, right? Joining point I to F, you could have quadratic, you could have cubic, and so on. So I'm just going to do simple case of linear function. And the easiest way to do a linear function is to actually define sort of a velocity. So find the velocity, what I'll do is I'll first define the time interval, which is going to be Tf minus Ti. And then I'll define dx, which is xf minus xi. And so if I want to find the x speed, it will just be vx equals dx dt, right? So in order to make the manipulator move along the x-axis, what I'll do is say that x position is xi, the start point, plus the velocity in the x direction, times t minus t I. Okay, so this is, you can think of this like Euler integration. It basically moves the x position by an increment which depends on the velocity. Okay, so I can do the same thing for y and z. So y, and then z. Okay, so this is the formula for x, formula for y, and then finally z. Okay, one more piece and we can test this code out. So this is basically giving the x, y, z position at a certain time t. We still need to set the position, and what we do is we simply use the set object position like we said before, except that now the position is not a single value, but it varies as time varies. So I need to have an array of x, y, z positions. So let me call that position ref, and I'll save position ref as equal to x, y, and z. Okay, so if everything works right, the manipulator end effector should move in a straight line from xi to xf, or position I to position f, in time 6 minus 3, which is 3 seconds. So it's real time start. So that's about it. I did not make it do more than that. So it looks like it works. If you want, you can try this for a slower speed. Let's just change this to from 1 to 7. So it's like taking 6 seconds, twice the time. So it's moving much slower than what it moved earlier. Right? So it's working. So let's change this to back to 3. So just 2 seconds. Okay, so now we can just, add this, take this idea and go for getting the manipulator to move back to the VR point. So what I'll do is I'll define a new time. We call that 5. And all I need to do now is I need to copy this code. And then just change the times, right? T2 to T3. And then my start position is the pick position. The end position is the via position. The initial time is T2 and the final time is T3. And then the move IK will take care of moving it. So let's run this and see what we get. So started from the via position, went to the manipulator and went back to the via position. So that looks good. So this code is working. Okay, so this is just going from one point to another point in a straight line, so it looks realistic and doesn't really goes in a jerky fashion like we had last time. So now let's see how we can compose a complete sequence from here, pick the box, go back to the via point in pink, well, grasp it before you go, then move back to the via point, then go to the black dot, place the box, and then move back to the via point. So there's a sequence of actions, and there are multiple ways of doing that. In fact, the closest example I can think of was the pendulum. When you did the velocity and position control, you were basically doing discrete actions, right? And depending on the place where the pendulum is. So I think it was starting from the vertically down position, you went up to, I think, 70 or 80 degrees and then switched to the position control. This is similar to that, except that there are more sequence of actions. So what I'm going to do is I'm going to use what is known as finite state machine for that. And let me just uh, tell you what finite state machines are. Basically, it's basically a flow chart of how things will move. And here's the link. The Wikipedia article is pretty good. So what happens in a finite state machine is you sort of have these bubbles, okay, or circles, which basically tells you a particular state in which the robot is. So the state could be go from point A to point B. That is one state. Another state could be pick up an object. That could be another state. So you always have a start state, and then there is a transition which determines the manipulator will go to the next stage. So in this case, let's say that the box, well, the manipulator went from the pink dot to the blue box when the time was 1 second, right? So that was the transition. So once it was at the blue box, then it had to pick the object. So then maybe the proximity sensor will tell it, now it's the time to pick the box, and we'll have a state 2, which is the picking. And then after that, we'll have transition, maybe time-based transition, it tells it now go back to the via point. So this is how we sort of take logic and put it in this finite state machine. Essentially has these bubbles where the action takes place, like the moving part, and then there is the transition, which is basically tells you how do you switch between these actions. So what I did was I took this picking a box and placing it to the goal and made it into this finite state machine. And I highly recommend that you do this yourself when you program anything more complex. You can think of it in your head, but it's always better to put it on paper. So we start, and we assume that we start in the VR point. VR point. At some time T1, we go from VR to pick. So that's going to be our state. In that state, you move the manipulator from pink to blue using the move IK function. Then at T equals T2, we pick, okay, the blue box. Then we wait for some time, and then we move from pick to via. After that, we go from via to goal. So that's over here. And then at goal point, we release the box, right? And finally, once the box is released, we go back to the via point, and then we stop. So that completes one set of sequence for the box to go from where it is to the goal point. And then we can do that for the second box, third box, and so on. So basically, we'll now program this building block as one function, And once we do that, we'll then be able to generalize it to multiple boxes. Okay, so let's see how this is done. Okay, so this is, you can call this as, actually can be coded as an FSM or finite state machine. So you can see that the transitions are here, right? And the main action blocks are here. So these are the, in when it comes to the diagram, these are the bubbles or circles. Okay? So I'm going to show you how this is normally coded. And again, there are many ways to do this. I find this particular way rather easy to code. So what I'm going to do is I'm going to specify states, just like there were states in the finite state machine I showed you. And we'll identify the state and we'll give the states numbers. So let's start with, let's call it state start. And I'm just calling it state start, not just start, because that way it's easy to identify it's a state. It's going to be a discrete number. So let's give that value of 0. Okay. And I'm using 0, 1, 2, 3 because that's easy to deal with numerics rather than to deal with strings like state start. Okay. So then after you get into the start state, you need to go from, and we're going to start at the VR point. You go from VR to pick, let's state 1. Once you're at the picking point, you have to grasp or pick, call that 2. After that, after picking the object, we go from pick to VR point, let's call that 3. So once you're at the VR point, which is this point, now you want to go from the VR point to the black dot. So let's call the next state as state VR to goal, black dot. Now once you're at the goal, you want to release the box. So let's call the next state goal state. So once you release the box, you want to go back to the VR point. So state goal to VR 6. And then once you're here, you know that you've done your task of placing the box. We will just go to a stop state. Okay, so those are the different states. Okay, and what we'll do in the code now is use this information to program the finite state machine. So what I'll do is, I don't think I need this anymore. Let me comment it out. Okay, there's an and here, which you need to also comment. Okay, so what is done in FSM is you pretty much, well, let's do it this way. So instead of specifying everything in the main code, let's just make a simple or single pick and place function. Okay, so this is going to be a single pick and place for one box. I will program that using FSM, and then in this main code, in the actuation code, I just need to call it 5 times if there are 5 boxes, 4 times 4 boxes, and so on. So let's just code this using a finite state machine. So I'll it here. And okay. Okay, so there are 2 pieces to writing a state machine. One is you have to define the transitions, all the arrows in that diagram I showed you, and all the actions, okay, or the circles. Okay, so I'll do that next. Any questions by the way so far? Okay, no questions. Okay, let's start. Okay, so we know that so first of all, the manipulator starts at the VR point. We know that it starts here. We also know that it's going to start in the start state. So any of these FSMs have to be initialized in the right state. Okay, so we tell the FSM to initialize in the start state. So let's keep track of the states in a variable called state, and we'll say that the initial state is the start state. Okay, so this is initializing FSM. And always I'll put the initialization in the init function because it's only called once. If you put it in the actuation, it will just keep refreshing and rewriting that. So this is, I set the state to 0. Okay. Now, once I've set it to 0, transitions are simply saying if state equal to state start. Okay. And now I'm talking about the transition from state start to basically going to pick the object, right? So what happens is I decided based on the, if you're in the start state and if the time is equal to, I think I chose it to be T1, then what I need to do is, of course, I define T1 as 1 second. So first transition takes at 1 second. Then what I need to do is so this is the cusp of transitioning from start state to the state where it's going to go from start state to the pick state, or the start state is actually, it's also the via point. So it's state, so that's basically the next state, which is state via to pick. So then I tell the transition to the transition condition to transition to the next state. So that's basically saying that the new state is that, and that happens when t is greater than or equal to t1, and then end, right? Now what I need to do in terms of actions is I need to just specify move ik. Okay. Now this move ik will occur only when the robot is in a certain state. If you don't have a condition on that, then it'll just be executed every time. So what I say is if state equal to state via to pick, then do move ik. Okay, now, though I set these up and the actions right, I still have not specified these variables. Now there's a choice. You could specify them here, right, inside this part, or you could specify here. In fact, I recommend specifying them in the transition. So those transition functions are usually called once per loop, but the action functions are called for multiple times in the loop. Okay, so I would specify them here rather than there because it's good to initialize. So this is set the transition, set transition, and initialize the state. So what does it mean to initialize the state? Here I'm initializing the state we have to pick. To initialize the state, I need to specify the start position, which is position of the manipulated in the start condition, which is the via point. And then I need to specify the position of the end, which is the position pick, which means it's going from the pink dot to the blue box. And then I need to specify the initial time. And the initial time is going to be T1, and then the end time. If you remember the end time, I specified with T2, and I think I randomly chose it to be 3 seconds. So T2. Okay, so I believe this code will work now because I initialized the parameters and made the box move in that state. Let's run this and see what happens. So picks the box. No, well, don't pick the box, but it just keeps going. It just keeps going because I did not tell it to stop. It just has to keep going. So what I'll do is always when you, and that's why that's the whole point of having a stop state. It is you want FSM to tell it if you've done something, you want to stop or you want to transition to the next condition. So let's just first program transitioning from going from via point to pick point to back to the via point, and hopefully that will, you'll see a pattern in the logic, and then I will program the stop state. So let's copy this essentially, put an else if. Okay, now this is programming the next transition, and I'm going to actually skip the transition involving, so I have transition of via to pick, then there's a picking operation. I'll program that later. Okay, at this point I'm just going from via to pick to via, so it goes from pink to blue, blue to pink, and I will not crash the object for now. So let's just do that. So state is via to pick, so that is it's exiting, it needs to exit this via to pick state, and I'm going to specify it's going to exit at T2, and then the state, the next state is, so after it goes from via to pick, it should go from pick to via, which is here to here. And then the start point is the picking point, the end point is the via point. And then the time is T2 and the end time is T3, which I need to define. Okay, so let's try this now. So it's going to do two things. One is go to the blue box and go back to the pink point. Okay, didn't go to the pink dot. There's some error in my logic. Let's see what it is. So I have the transition right, but I have not set the state. I did not perform any action there. Remember, I need to set what it needs to do in which state. So here, what I need to do is I also need to tell it that if you're in state pick to via, then this or this, you need to do the move IK. So let's see if this works. Okay, that worked. In fact, it just kept moving. So how do I stop this? Well, as I said, the stop state is useful. The stop state is supposed to be something where it tells the finite state machine, stop now, don't do anything. So what I'll do is I'll program a stop state just after this one. So if it is in pick to via, how did I get this? Well, it basically is just the same state because I'm going to transition from pick to via to the stop state. And then I want to decide to stop at 3 seconds or T3 seconds. And since there's nothing really happening in this state, I do not need to specify the start and end. So I have not programmed any actions because in the stop state, the manipulator is not going to do anything. So let's see what happens if we run this now. Okay, sort of did what we wanted, stopped. Okay, now what we're going to do next is we have to program this for the entire state machine encompassing all these states from 0 all the way to 7. Okay, so before I do that, I think it's really tedious for me to specify T1, T2, T3, and so on. So what I'm going to do is I'm just trying to find a pattern in these times so that I don't have to manipulate so many variables or define T4, T5, T6. But of course, you can do that. So what I'm going to do is I'm going to sort of make some observations here. So first of all, I looked at this is T1 and this is T1. If this is T2, then this is T2, and so on. So it seems that the T2 is basically the TF of the previous one. So I'm going to write this as TF, same as that. And then this is also TF. Okay. Okay, that's good. Now, what about the, well, so this T2, it seems like it is basically T1 plus 2, right? I'm just trying to make it uniform. Okay. So then you can see that this T2, well, T2 is T1 plus 2, which is basically T1 plus, let's just make this duration constant. So let me put a duration of 2 seconds. This becomes duration. So I'm doing this again. I said I'm just doing this to make it easier to code. You do not have to do this. You can just rely on specifying these variables. T1 plus durations will be T2 plus duration, so on. Okay, I can do actually more simplifications here. I can actually specify this. So since I want all this to be TF, I'm just going to define my TF right in the beginning to be 1. And then this is TF because the same value T1. Okay, so I see a pattern, it's all TF. And now I think that I don't want to keep it at T1, T2, so on. So what I'll do is, since that TF comes here, which was the same one over here, I'll just define as TF. This T2 was basically here, so it's TF. And then this T1 was over here, so it's going to be TI. So if you think this is confusing, as I said, you're free to not use this, but use different times. So I think this way, it actually is simple in terms of programming, because everything here in this code doesn't depend on any of the variables over here. So this ensures that every instant of the finite state machine is executed in 2 seconds. Okay, if you don't want this, then you'll have to do more changes. Let's see if this works. Uh-oh. Okay, so there was some problem in my change. So what happened, I think, was my TF it keeps changing every iteration. So if I want to initialize something, I don't want to initialize it in the single pick and place, because every time it's being initialized to 1 second, I don't want that. So as I said, any initializations have to go in the initialization part of the code, which is right here. So I'm going to initialize right here. Okay, I think your TI is in your move IK function. I think this should work fine. Anyway, I think this is the error. Let's see if this works. Yeah, so it works. So the initialization was incorrect. Okay, so what I achieved by doing all that, making it, some people find it confusing, is that I did that only because I can now easily copy paste. I do not have to write special things in the code, as you'll see as I go and program more steps. So I'm going to now program the entire state machine, because I have sort of made these blocks look very similar to each other. Okay, so let's go and start programming the state machine. Okay, so first state start. From the start, we go to VR to pick. So VR to pick, and now we need to pick the object. So what we'll do is we'll essentially copy this. Well, my bad. Let me copy this. So when I'm going from VR to pick, I need to go to the next state, which is actually pick the box here. So I'm going from here to here. Now I pick. And when I'm picking it, I really don't need to do all this. So I just skip that because I don't want to use the IK, right? So once I'm in the pick state, then I need to go to pick to VIA. So I pick the box, I go from pick to VIA. So pick and VIA is right. Everything looks fine. Should put else if here. Okay, because there'll get an error. Okay, got that. Now let's see where we are. So I got from, so now I'm at pick to VIA. So pick to VIA, I need to go from VIA to goal. So what I do here is say this thing over here will be the same as the previous initialization. So it's going to be pick to VIA and then VIA to goal. Okay, the start state is VIA, same as this. The goal state, the final state is going to be the goal state. Okay, so right now I'm right here. I need to go from, I'm VIA to goal. So I'm going to the goal. At the goal point, I need to release the block. So in this case, it should be similar to this one. Only one action of releasing the block. State release. And then when it's in the release, it needs to transition from release to goal to VIA. So it's released here, it goes from goal to the VIA point. And once it goes to the VIA point, I need to stop. So then I'll have a goal to VIA here. And I'm missing something here, which is initializing the TITF, because that is invoking move IK. So the start state is the goal state, which is here. The end state is the VIA state. Okay, so I sort of built up a pattern which made it easier to program the finite state machine. Okay, so this completes the transition. I, however, need to specify the action. So let's keep doing that. We want have state equal to state VIA to goal, or state equals goal to VIA. Okay, these are all the states where you need to move. We also need to tell it what it needs to do when it's in these states, the pick state and the release state. Oh, I don't have a release, so I need to think I'm missing something. Pick to via. So pick to via, then via to goal. When I go to via to goal, I need to release. I'm missing something here for sure. I need to have a state release, which is not appearing here. Okay. Let's see. So pick to via, pick to via, via to goal. So it reaches the goal. Oh, this is wrong. This has to be if via to goal. Then it needs to transition to state release, and nothing will take place there. This is just going to release. And then I should have goal release. So if it's in state release, then go to goal to via. Okay, now I need to program the last two actions. State equals state pick. All I do is make it pick the object, which is function I already wrote, grasp object. And then I need to specify a goal state release, which I just do detach the object, or it's right here. Okay, so the way I define this is I have to give it the handle shape attached, and the shape attached is nowhere in this code. So I need to dig in and find what the shape attached is. It's basically the object which is grasped, right? So in my grasp object here, I'm actually returning the attached shape. So I better collect it. The way I collect it here is I just say shape attached equals grasp object, which means that grasp object is returning the shape object. It is being returned, and so it's stored here, and then it's being used to release the object. So I think this is all to it. Okay, I'm missing something. The error is then 112. 112 right here. Okay, let's start now. Okay, so that looks good. It did what it's supposed to do. It is a single pick and place. Okay, and the good part of this is that once you do that, it's just a matter of figuring out how to do multiple pick and place. Okay, so what I'll do is I'll create more boxes now. Command C, Command V, move the translation, and then move it down. Okay, and clearly when I run this, it's still going to do one pick and place. So I need to figure out a way so that the manipulator can detect all the boxes and then just do multiple pick and place. And so what I'm going to do is I'm going to rely on some of the code I developed in the last lecture. Remember, I developed a code where it would identify the boxes in the scene using in the grasp object. So that code is right here. So this was grasp object. It was basically cycling through all the shapes, getting objects in the scene, and then using those shapes to detect if the proximity sensor detected the object or not. I can take this code and modify it to suit my purpose, which is it will basically go through all the objects and identify the shapes which are dynamic, or the boxes, so that I can then sort of automate the process of going pick and place. So let me take this code, only this much, and move it to the init, because the initialization is where I would get all this information. Okay, so let's see. I don't need this. I don't need this. I'll just comment it out for now. I don't need it at this moment. Okay, so what this does is it goes through all the indices and gets all the shapes, right? Let me create an array called objects to move, which will keep track of all the objects I need to move. and I'll initialize to null array. Okay, now what I'll do is I'll basically find the shape, which is the box, and then add it to that objects to move. And that way I'll have a list of all the objects I need to move. So the way I do it is um, I know that all those shapes in the scene, the boxes basically have, so other objects are static, but the boxes are not static. So I'm going to use this parameter. Okay. So then I say that if parameter 2 equal to 0, okay, that is if the shape here I've written, if shape is static, then it'll return parameter 2 equal to 1, but the shape is dynamic, so it'll return parameter 2 equals 0. So then I say what I need to do is I need to basically insert that into object to move. So the command for do that in Lua is table.insert. Okay, and the way I got it is just by searching it. How do you add a element to an array? So what I need to do is objects to move. I need to add the object which I identify, which is shape. Okay, and then end. Okay, now if you want to verify this, we can just do print objects to, okay, we know there are two objects, the box values, which it should be outputting. So let's just do this, and let's just comment it out because we don't want to move the manipulator. So you can see here, you see 30 and 31, that means it has identified two boxes. Okay, now what remains to be done, the last step is we want the manipulator to pick each of those boxes and move it to the goal. Okay, so that's the last part. Okay, let's do that. Okay, so first of all, I'll eliminate a few things. I do not need to keep track of the box. I do not need to keep the pick position because that will be dynamically set in the code. And so let's go ahead and program the final part. Okay, so first of all, what I do is I say position pick, right? The position pick is not being specified, but I want to specify it by using the same thing which I did here. So the position pick was, well, it was here, I don't need this. Okay, so that had the handle of box, but now this handle is stored inside objects to move. So I say position pick, and then this element is going to be objects to move, and then I need to specify which object it is, right? So in this case, let's give it an identifier box number, and where what I'll do is I want to initialize this box number to 1 because that'll be first box, and then I want to change that to number 2 and so on. I'll do it automatically in a bit, but before that, let me first specify the pick position. I also need to specify this, if you remember, I can't attach the box to the position pick because the position pick is the center of the box. I need to attach not here, but attach there. So that's why I need to do -0.1 on the y coordinate. Okay, so that's done. Now what I do is single pick, and okay, it's already here. Let me just run this. Okay, there is an error 73. There's an extra space here. Okay, let's run this. Okay, that worked fine. Okay, that worked fine. But let me, what I'll do is now I need to get it to pick the second box. So what I'll do in this case is, well, first of all, I need to know that the whole FSM did complete, right? Went from the start state to the stop state. So the way I can do this is by ensuring that the single pick and place function returns the state. Okay, and when that state equals the stop state, I know that the single pick and place worked. So this is a return value. I have not programmed the return value yet. So I go to single pick and place, and right in the bottom, I say here, say return state. Okay, so it returns the state. And now I know if the state is, if state equals to state stop, okay, end state, Then all I do is I refresh the state to be state start. Okay, that's reinitializing the FSM. I change the box number to box number +1 and I end. Okay, and there's one more thing which I should do, which is remember I initialize the start state. I also initialize TF. So let me just initialize the TF. It should be the new simulation time. So it will be this. So that way time is also implemented. I need to initialize these three things every single time and go for the next box. Okay, that's done. Let's run. Okay, it did finish, but there was an error, right? It was an error because it just kept going and did not know when to stop. You also need to tell it to stop picking the boxes when all the boxes have been picked up. So what I do is here is I also say and stop when the number of boxes is, in this case, the boxes are 3, right? So box is less than, less than 2. But if I do that, if I hard code number 2, that will only work for 2 boxes. So what I do is there is a way in which I can get the number of boxes. It's essentially the length of the objects to move. And so the command for that, which I again found from searching on the internet, is if you want to find the elements of objects to move, or the equivalent in MATLAB is length, then you do table.getInN. So I just do this. And now it should work. Let's see, was getN is not table.getIn objects to move. Oh, because objects to move, not object to move. Okay, attempted 78, attempted to access nil. Oh, this is incorrect. It should be box number, my bad. Okay, I think I finally figured it out. Okay, so it's 10:50. Just give me 2 minutes and I'll be done with this. I just have to show you that it works for any number of boxes you throw in the scene, and then I'll put the red cube and show that it works in that case. So give me 2 minutes. I'm almost done. Okay, no error. Okay, let's first of all add more boxes. Okay, I added one more box. Let me also add a cube. One, it came there. Let me move it down. So now it's really constrained because now if it moves, it's actually going to bump into the cube. Let me change the color. For that I need to go here and then change the color. And then let me do one more thing, make it static, otherwise it will be picked like in the normal object. So let me make it static. Okay, so let's start this now. Okay, now you can see it's actually bumping into the red cube, and this is not what we want. And this is where it's useful to have the via point, and I'll show you how you can manipulate the via point to get it to be done. I'm almost done. Let me stop this. So it was bumping. So what I'm going to do is a very simple step now. It's just going to move the via point. I know that if I move the via point, maybe here, okay, it'll be a clean move because it'll pick it up that way and then it'll go down. Let's see what happens now. Okay, there's a clean move for the first one. Just missed the cuboid. Okay, just missed it. Okay, so that's it. So that's how you do pick and place.